Myself Mydhili from Emmanuel Sir JJ College of Engineering, Department of Computer Science. Today we are going to see about graphs, basic representation, traversals and application. It will come under CS 3401 algorithms. So before that, what do you mean by data structure? I will explain you. Data structure is a collection of data arranged in a manner. There are two types of data structure. One is linear data structure, the other one is non-linear data structure. Linear data structure means the data will be arranged in a sequential order or in a linear manner. That is called as linear data structure. Linear data structure example: stack, queue, array. Stack means last in, first out. For example, I am keeping the book at the last, first I am taking it out. That is called as stack. Queue means normal queue. I am going and standing in front, I am getting the things and I am going out. The person who is come will be entering at the end of the queue. So in the queue, usually insertion take place in the end of the queue and deletion will take place in the front of the queue. The same way array. Array is a collection of homogeneous or similar data type. That is called as array. So here we are going to see about graph. So what do you mean by graph? Graph is a non-linear data structure, consists of vertices and edges. So what do you mean by vertices? Here see, the circle is called as node or vertices. It is represented by circle. Edges means the line connecting the nodes. It's called as edges. So graph is a collection of vertices and edges. So it is represented G. G represent graph. B comma E. B represent vertices. E is a edges. There are two types of graphs. One is directed graph, the other is undirected graph. So directed graph, a graph with only directed edges is said to be directed graph. So here see, arrow is there, that is called directed graph. Consider, before I have told you, the circle are called as nodes or vertices, the line connecting is called as edges. Okay. Here what are the vertices you have? 0, 1, 2, 3, 4. So from 0 where it is connecting to 3 and to 2. For 1 it is connecting to 0. For 2 it is connecting to 1. Next for 3 it is connecting to 4. For 4 it is connecting to 0. It is said to be directed graph. Undirected graph, there is no point out. So same here, the circles are represented nodes or vertices. The line connecting the vertices or nodes is called edges. The graph with only undirected graph is said to be undirected graph. Next one, representations of graph. There are two types of representation. One is adjacency matrix, next one is adjacency list. So what do you mean by adjacency matrix? In this representation, the graph can be represented using a matrix format. Okay, where n is the number of vertices. The matrix is filled with only zeros and ones. One represent, there is a edge from row vertex to column vertex, and 0 represent there is no edge from row to column vertex. So same way adjacency list. In this representation, every vertex of the graph contains of its adjacent vertices. If the graph is not diminished, the number of edges will be less. We can see the example, adjacent matrix versus adjacency list. So adjacency matrix, it is given in undirected graph. What do you mean by directed graph? If we are pointing, it is called as directed graph. If we are not pointing, it is called as undirected graph. Here it is undirected graph. Consider a adjacency matrix. What are the vertices we have? The circle are called as vertices or nodes. The line connecting are called as edges. So what are the vertices we have? A, B, C, D, E. Same A, B, C, D, E. So consider A to A. It is the source node. So 0. A to B. Only one edge is there. A to C. Only one edge. A to D. Only one. A to E, no edge connecting. So it is 0. The same for B to A. B to A, same 1. B to B, 0. B to C, no edge connecting. So 0. B to D, 1. B to E, 1. Next, C to A, 1. C to B, no edge directly connecting. So 0. C to C, 0. C to D, 1. C to E, no edge directly connecting. So let it 0. Next, same for D to A. D to A, 1. D to B, 1. D to C, 1. D to D. D to D, here it is represented as circle. Please see, here it is represented circle, so it has a one node. So it is considered as 1. D to E, 1. E to A, no direct edge, 0. E to B, 1. E to C, 0. E to D, 1. E to E, 0. Same here, adjacency list. In a list format we will give. It is also a undirected graph. Here circle are represented nodes or vertices. Line connecting the vertices are called as edges. So for 0, 1, 2. For 1, 0, 2. Next for 2, 0, 1. It is called as adjacency list. So now we can see where and all places applications of graphs. Where and all it will work. First one, neural networks. Vertices represent neurons. Edges are the synapses between them. Network packet traffic graphs. Vertices are IP, Internet Protocol, and the edges are the packets that flow between them. Protein-protein interaction graph. Vertices represent proteins and the edges represent interaction between them that carry outcome biological function in the cell. Graphs in epidemiology. Vertices represent individuals and directed edges to view the transfer of infectious diseases from one individual to another. Graph traversal. Graph traversal is a technique used to search for a vertex in a graph. It is also used to decide the order of vertices to be visited in the search process. This is an important question in CS 3401 algorithm. There are two types of graphs traversal. One is depth first search, the other is birth first search. So first we can see about depth first search algorithm. It is called as DFS. It is a depthward motion and uses a stack to remember to get the next vertex to start a search when a dead end occurs. BFS, birth first search. So circles are represented vertices. Line connecting are called as edges. So first node will be the source node or the parent node. So it will be output in layer by layer. So 0 is in the first layer, 1, 2, 3 in the layer 1. 4, 5, 6 in the layer 2. So what will be the output? 0, 1, 2, 3, 4, 5, 6, 7. depth first search. The first node will be considered as the source node. The out will be 0, 1, 4, 5, 2, 6, 3, 7. Next one is birth first search. It is BFS in a birthward motion and uses a queue to remember to get the next vertex to start a search. End occurs in any interaction. So by connectivity graph. An undirected graph is said to be bi-connected graph if there are two vertex disjoint path between any two vertices are present. In other words, we can see that there is a cycle between any two vertices. Bi-connected, see 0, 1, 2, it is bi-connected. It is forming a loop, interconnected, that is called as interconnected. Same way here, 0, 3, 4, 2. So minimum spanning tree. A minimum spanning tree or minimum weighted spanning tree for a weighted connected undirected graph is a spanning tree having a weight less than or equal to the weight of every other possible spanning tree. So minimum spanning tree is called as MST. What do you mean by spanning tree? It has a minimum values at the left side, that is called as minimum spanning tree. Algorithm used for finding minimum spanning tree is Prim's algorithm and Kruskal's algorithm. First we can see about Prim's algorithm. What do you mean by Prim's algorithm? It's a minimum spanning tree algorithm that takes a graph as input and finds the subset of edges of that graph, which form a tree that includes every vertex. And it has a minimum sum of weight among all the trees that can be formed from the graph. Consider this as a graph. Here what are the vertices? 1, 2, 3, 4, 5, 6, 7. These are the vertices. What are the edges? The line connecting the vertices are called as edges. The red color marked label are called as weight. So here consider a minimum weight. So first, which one has the minimum weight? Consider. Which has the minimum weight? 1, 2, 6. The value will be 10. Okay. And step 1, consider the minimum weight 1, 2, 6. The value will be 10. And see the adjacent node for 6. What are the adjacent node for 6? 1 and 5. 1 already we have taken. 5. It is 25. Okay. After that for 5, what are the adjacent node? 7 and 4. Here which one is less weight? 5 to 4, 22. Next for 4, consider which are the adjacent node for 4? 7, 3. 3, the weight will be 12 and for 7 it is 18. So consider 4 to 3 as 12. Next step 5. Step 5, consider for 4. Which are the ends? 3 and 7. Which has the less weight? 4 to 3, 12. Okay. Next for 3. 3 to 2 and 3 to 4. 3 to 2. Okay. Next for 2. 2 to 1, 2 to 7. Which has the less weight? 2 to 7. And calculate all the values and we will get a final value, that is the total value, that is called as Prim's algorithm. What we will do, the Prim's, once again I will explain. Consider all the vertices and line connecting is called as edges. Consider first the minimum weight, that is 1 to 6, and choose the adjacency of 6. Like that you go on, that is called as Prim's algorithm. Next one, Kruskal algorithm. Same as Prim's algorithm, but here we don't get a loop. Okay, consider a minimum weight. The same example we can take. Consider a minimum weight. as a input and finds the subset of edges of the, consider this graph. Okay, here what are the vertices? 1 2 3 4 5 6 7. Okay, first consider the same here, 1 2 6 10. Next, what is the minimum weight? 4 2 3, consider it. Okay, then what is the minimum weight? 7 2 2. Here consider all the minimum weight edges, okay, which does not form a loop, that's all. Okay, first one 1 2 6 10, and draw. Second step, draw 4 2 3 12. In the third step, 7 2 2 14. Next 7 2 4 18. Next 4 2 5 22. If we draw 24, here it will form a loop. So skip the value 7 to 5 and draw 5 to 6 25 and calculate the weight. That is Kruskal algorithm. Next, shortest path algorithm. The shortest path problem is about finding a path between vertices in a graph such that total sum of the edges weight is minimum. There are so many algorithms. First one is Bellman-Ford algorithm, Dijkstra algorithm, Flyd-Warshall algorithm. So first one, Bellman-Ford algorithm, helps us to find the shortest path from a vertex to all other vertices of a weighted graph. It is similar to Dijkstra algorithm, but it can be worked with graphs in which have negative values. So consider a graph. A, B, C, D, E, F, G. So this is a weighted graph because it has arrows. The circle represents vertices or node, and the line joining the two vertices is called edges. So every node have a value. So it is considered as a weighted graph. So A is the source node, so it is colored in yellow. Okay, consider A as the source node. Put remaining all vertices as infinitive first. Okay, next A to F, the value will be 3. 0 plus 3, 3. Okay, next A to B, 0 plus 2, the value will be 2. For B, the value will be 2. For F, the value will be 3. Next, A to D. Consider A to D. 0 plus 5. The value will be 5 for D. Okay. Next, for B. B to E. B to E. Now the value of B is 0, minus 4, minus 4. Okay. So, minus 4 plus 1 equal to the value of E will be now 3. Next, E to G. The value will be 3 plus 3. The value for G will be 6. Next, E to C. 3 minus 3, 0. The value for C will be 0. And for G, G to D, 0, 6 here. 6 minus 1, 5. Already the value of D is 5. So update the values. That is called Bellman-Ford algorithm. Next one is Dijkstra algorithm. Dijkstra algorithm allows to find the shortest path between any two vertices of a graph. It differs from the minimum spanning tree because the shorter distance between two vertices might not include all the vertices of the graph. So V1, V2, V3, V4, V5, V6. Okay. Next, V1 to V2, the value will be 9. V1 to V3, the value will be 4. V2 to V4, the value will be 7. What is the Here see the circle are represented vertices. The line connecting are called as edges. So consider V1 will be the source vertex and V5 will be the destination vertex. Okay. So source will be always 0. 0 plus 9, the value will be 9. Next, 0 plus 4, the value will be 4. Find same way, find the shortest distance. So you will get the distance. This is called as Dijkstra algorithm. Next one, Flyard-Warshall algorithm. Flyard-Warshall algorithm is an algorithm for finding the shortest path between all the pairs of vertices in a weighted graph. This algorithm works for both the directed and the undirected graph. But it does not work for the graphs with the negative cycle. Negative cycles means before we have seen in the Belmont algorithm, it is given as -4, minus. Here the values with the negative values won't be taken. The weighted graph is a graph in which each edge has a numerical value associated with it. Flyard-Warshall algorithm is also called as Flyard's algorithm. Thank you. Have a great day.